Have you ever wondered what makes a computer tick? What allows us to type a letter, watch a video, or play a game? The answer lies in computer hardware. Hardware refers to the physical components of a computer system. Think of it as the bones and muscles of your computer. These components work together in perfect harmony to make your digital world come to life. From the keyboard you use to type to the screen you're reading this on, each part plays a crucial role. Understanding these components can be incredibly beneficial, even if you're not training to be a computer scientist. Knowing how your computer works can help you troubleshoot problems, choose the right upgrades, and gain a deeper appreciation for the technology we use every day. Imagine trying to tell someone something without using your voice or any gestures. It would be pretty difficult, right? That's essentially what it's like for a computer without input devices. Input devices are the tools that allow us to communicate with computers. They convert our instructions and data into a language that computers can understand. Think of a keyboard. When you press a key, it sends an electrical signal to the computer, which is then translated into a specific letter or command. There are many different types of input devices, each designed for a specific purpose. Some of the most common ones include keyboards, mice, scanners, and microphones. These devices bridge the gap between our physical world and the digital realm, making it possible for us to interact with computers in meaningful ways. In the physical world, we use our hands to point, gesture, and interact with objects. In the digital world, we need a different kind of hand, a pointing device. Pointing devices allow us to control the movement of the cursor on the screen, making it possible to select objects, open files, and interact with applications. The most common pointing device is the mouse. It's a small, handheld device that you move across a flat surface to control the cursor. But mice aren't the only pointing devices out there. Touchpads, found on most laptops, let you control the cursor by moving your finger across a sensitive surface. Trackballs, often used in gaming and industrial settings, provide precise cursor control through a rotating ball. Each pointing device has its own strengths and weaknesses, and the best choice for you will depend on your individual needs and preferences. In the age of digital information, we often find ourselves needing to convert physical documents into digital formats. This transformation is essential for preserving, sharing, and accessing information efficiently. That's where scanners come in. They serve as the bridge between the physical and digital worlds. Scanners are input devices that capture images from physical objects, such as documents, photographs, and even 3D objects, and convert them into digital images. This process allows us to create digital archives of important materials. But scanners are only part of the story. The real magic happens after the scanning is done. Once we have a digital image, we often need a way to extract information from it. This is crucial for making the data usable and searchable. That's where optical recognition technology comes in. It enables us to transform static images into dynamic, editable content. Optical character recognition, or OCR, allows computers to read text from images and convert it into editable text. This technology is a game changer for digitizing printed materials. Imagine scanning a handwritten document and having your computer instantly convert it into a digital text file that you can edit and share. This capability saves time and enhances productivity. Other types of optical recognition include optical mark recognition, OMR, commonly used to grade multiple-choice exams, making the grading process faster and more accurate, and magnetic ink character recognition, MICR, used by banks to process checks. This technology ensures the secure and efficient handling of financial documents. These technologies have revolutionized the way we handle information, making it easier than ever to digitize, store, and access important data. The digital age has truly transformed our interaction with information, making it more accessible and manageable. Section 5. Output devices, bringing information to life. Input devices are essential for getting information into a computer, but what about getting information out? That's where output devices shine. Output devices take data processed by the computer and present it to us in a way that we can understand. This could be in the form of text, images, sound, or even physical objects. One of the most common output devices is the monitor. Monitors display images, videos, and text from the computer, allowing us to see the results of our work and interact with the digital world. But output isn't limited to just sight. Speakers are output devices that produce audio, allowing us to hear music, watch movies, and communicate with others online. From the printed page to the vibrations of a speaker, output devices bridge the gap between the digital world and our senses, making it possible for us to experience and interact with information in meaningful ways. Section 6. Printers, from ink to paper. While we live in a digital world, there's still a need for physical copies of documents and images. Despite the convenience of digital storage, nothing quite replaces the feel of a printed page in your hands. That's where printers come in. They bridge the gap between the digital and physical realms, making it possible to hold a piece of your digital work. Printers are output devices that produce hard copies of digital documents and images. They transform digital data into tangible items you can touch, share, and store. They come in various shapes and sizes, each using different technologies to transfer ink or toner onto paper. From compact home printers to large industrial machines, there's a printer for every need. Inkjet printers are popular for home and small office use. They are versatile and can handle a variety of printing tasks, from simple text documents to vibrant photos. They use tiny nozzles to spray liquid ink onto paper, creating high-quality text and images. This technology allows for detailed and colorful prints, making them ideal for photo printing. Laser printers, known for their speed and precision, use a laser beam to bond toner powder onto paper. This method is efficient and produces sharp, clean text, perfect for professional documents. They're ideal for high-volume printing tasks where speed and efficiency are crucial. Offices and businesses often rely on laser printers for their reliability and low cost per page. Then there are three-dimensional printers, which take printing to a whole new dimension. These printers can create complex objects that were once impossible to produce with traditional methods. Instead of ink, they use materials like plastics and metals to build three-dimensional objects layer by layer. This additive process allows for intricate designs and custom creations. Three-dimensional printing has revolutionized manufacturing, prototyping, and even healthcare. It enables rapid prototyping, personalized medical devices, and innovative product designs. Whether you're printing a simple document or creating a complex three-dimensional model, printers provide a tangible link between the digital and physical worlds. They make it possible to bring your digital creations to life. Section 7. Processing Powerhouse, the CPU. At the heart of every computer lies its brain, the Central Processing Unit, or CPU. The CPU is responsible for executing instructions and performing calculations, essentially acting as the brain of the computer. It fetches instructions from memory, decodes them, and then executes them, performing arithmetic, logical, and input-output operations. Think of the CPU as a conductor of an orchestra. It controls and coordinates all the other components of the computer, ensuring they work together harmoniously. The speed and efficiency of the CPU significantly impact the overall performance of the computer. A faster CPU means programs load quicker, games run smoother, and tasks are completed faster. Section 8. Networking and memory connecting and storing data. In today's interconnected world, computers rarely operate in isolation. They are part of a vast network that spans the globe, connecting millions of devices and enabling seamless communication. Networking devices such as network cards and modems allow computers to connect to each other and to the internet, enabling communication and data sharing. These devices are the backbone of our digital infrastructure. Network cards provide a physical interface for connecting to a network, ensuring that data can be transmitted and received efficiently, while modems convert digital data to analog signals and vice versa, allowing data transmission over telephone lines or cable networks. This conversion is crucial for maintaining the integrity of data as it travels over various mediums. But what about storing all the data that flows through our computers? This is where memory devices play a pivotal role. That's where memory devices come in. They ensure that data is readily available for processing and long-term storage. RAM, or random access memory, is the computer's short-term memory. It temporarily stores data that the CPU needs to access quickly, making it essential for smooth and efficient operation. It temporarily stores data that the CPU needs to access quickly, allowing for faster processing and multitasking. Hard drives, on the other hand, provide long-term storage for files, applications, and the operating system. They are the repositories of our digital lives. They come in two main types, each with its own advantages and use cases. Hard disk drives, which store data on spinning platters, are known for their large storage capacities and cost-effectiveness. and solid-state drives which use flash memory for faster data access. SSDs are prized for their speed and durability, making them ideal for high-performance applications. Together, networking and memory devices ensure that computers can connect, communicate, and store the vast amounts of data that fuel our digital lives. They are the unsung heroes of our modern world, enabling everything from simple emails to complex data analysis. Section 9. Conclusion: the future of computer hardware. From the humble keyboard to the powerful CPU, computer hardware forms the backbone of our digital world. Understanding these components empowers us to make informed decisions about the technology we use and to appreciate the complexity and ingenuity behind the devices we often take for granted. As technology continues to advance at an unprecedented pace, we can expect to see even more innovative and powerful hardware emerge. Quantum computing, neuromorphic chips, and even more powerful GPUs are just a glimpse into the future of computing. With each new advancement, the line between the digital and physical worlds blurs, opening up exciting new possibilities for how we live, work, and interact with the world around us.